For ages, people have looked up at the night sky, wondering about all the secrets out there. Back in the 1900s, scientists came up with the Big Bang Theory to explain how the universe started, how it's grown, and why it's still growing. Though it's a common idea, it still doesn't answer everything about space. Recently, some big finds have made these mysteries even harder to figure out. For example, in 2023, NASA's James Webb Space Telescope spotted stuff that looked older than the universe itself. This shocked scientists and started a big argument. Could stars really be older than the universe they're in? Webb's discovery has challenged what we thought we knew about space and time, making us think we might need to change our whole model of the cosmos. These are the kinds of questions we'll be looking at. If you're into space and want to know about new finds, be sure to subscribe, like, and turn on notifications so you don't miss anything. Around 200 light-years away in the constellation Ophiuchus, there's a really interesting star called HD 14283. It's not just fast, moving at 4,483 kilometers per second, but it has a cool story. About 1 billion years ago, when the Milky Way was forming, it crashed into a smaller galaxy. This star survived that crash. But what makes HD 14283 special is its age. It's nicknamed Methuselah, after the guy in the Bible who lived for almost 1,000 years, and it's one of the oldest stars we've ever seen. At first, they thought it was 16 billion years old, but now they think it's about 14.46 billion years old, give or take 800 million years. That's still older than the universe, which we think is about 13.8 billion years old based on cosmic microwave background radiation data. So, how can a star be older than the universe? This head-scratcher has made scientists rethink how we measure the ages of stars and the cosmos, pushing us to look into these confusing space puzzles. To get why this is so weird, you have to know how hard it is to guess a star's age. Stars like our sun stay pretty much the same size and temperature for a long time, so it's tough to know how old they are. Astronomers have to watch for tiny changes in their light and color and compare them to models of how stars change over time. One way they do this is by looking at how fast a star spins. Like a top that slows down, stars lose their spin over time. By measuring this and comparing it to stars we know the age of, scientists can guess a star's age. Methuselah is definitely old, and right now, it's the oldest star we know. But instead of worrying about whether it's more than 2 billion years older than the universe, maybe we should ask if the universe is older than we thought. It's hard to imagine 13.8 billion years. Imagine squeezing all of space history into 1 year. The Big Bang happens on January 1st, Earth doesn't show up until the last hours of December 31st, and all of human history is just the last few seconds of that year. Astronomers figured out the age of the universe by studying light from really far-off stars that formed soon after the Big Bang and by looking at redshift, which is when light stretches out as the universe expands. This gives us the 13.8 billion year estimate. But someone at the University of Ottawa thinks this might be too low. They say the universe could be around 26.7 billion years old. This idea comes from physicist Rajendra Gupta, who looked at a theory from 1929 by Swiss astronomer Fritz Zwicky and combined it with new stuff. Gupta thinks that protons lose energy over huge amounts of time and distance, which goes against how we see redshift. Instead of just blaming redshift on the universe growing, Gupta thinks it might be a mix of things. If he's right, it could totally change how we think about the age of the universe and maybe even solve some old debates. A lot of these debates have come up because of recent finds from NASA's space telescopes. Gupta's theory uses the idea of tired light and adds something called evolutionary coupling constants, which theoretical physicist Paul Dirac came up with. This suggests that the forces in space might have changed over time. It's worth remembering that our ideas about the age of the universe have changed a lot. Back in the 1920s, Edwin Hubble thought the universe was around 2 billion years old. Over time, better observations have pushed that number up to 13.8 billion. Whether you think of human history as seconds or milliseconds on the cosmic clock, the universe is incredibly old, and it's still growing, which makes us question what we thought we knew. Meanwhile, scientists are finding cool things about the Milky Way. For example, stars on the edge of our galaxy move slower than stars in other galaxies. One idea is that the Milky Way has less dark matter than we thought. Dark matter is invisible, but it affects how gravity works in space. Another idea is that we don't know how dark matter is spread out across the universe. This mystery comes from data gathered by the European Space Agency's Gaia mission, which has mapped almost 2 billion stars in our galaxy. These finds have made astronomers rethink how stars act, especially at the edge of the Milky Way. The speed at which stars orbit depends on how much stuff is in the galaxy, both stuff we can see and dark matter. A recent look at Gaia's data suggests that the Milky Way's mass, including stars, gas, dust, and dark matter, might be about 200 billion times the mass of our Sun, which is 5 times less than we thought. This could mean there's not much dark matter. Still, figuring out a galaxy's mass is super hard, and mistakes in the data or models could mess up the results. As we get better data and instruments, we'll keep following these stories. Looking ahead, new tech and space missions will probably solve some of these space puzzles. The James Webb Space Telescope is pushing scientific limits like never before. It's not just about guessing the ages of stars or the universe, it's also showing us how galaxies work, the weird stuff about dark matter, and the forces that shape space. The expansion of the universe is still a big mystery, but as we get new info, we might find out that what we thought was right was wrong. A big question is whether the laws of physics work the same everywhere in the universe. Could there be hidden forces that affect how galaxies act and how stars age? As our instruments get better, we might find things that shake up modern science. Experts are starting to realize that we're just scratching the surface when it comes to understanding dark matter, dark energy, and the basic forces that run the cosmos. Every new look at far-off galaxies or old star stuff gives us clues about how the universe works, but these clues often make us ask even more questions, pushing the limits of what we know. The idea that stars might be older than the universe or that the cosmos is older than we thought makes us rethink everything about space. It means we might need new physics, ideas, and a new way of looking at space and time. These changes don't just affect science, they make us think about big questions about reality and our place in it. If these finds are true, they could change what we think we know about existence. As we argue about the universe's real age, it's clear that we're starting a new chapter in space exploration. The next few decades might answer questions that people have been asking for thousands of years. Whether it's finding stars older than the universe or solving the puzzles of dark matter and energy, the universe is still hiding secrets. The way forward is all about asking questions, testing ideas, and making our understanding of everything out there better. Even though we don't have all the answers, the search for knowledge is just beginning. So, stay tuned for more updates on these amazing finds and ideas. Keep your curiosity alive because the future might bring amazing breakthroughs we can't even imagine yet. If you love space science and want to stay in the know, subscribe to our channel, hit the like button, and turn on the notification bell so you never miss an update. As we go deeper into the universe, we're on the verge of changes. The James Webb Space Telescope has already given us great pictures and info about galaxies, planets, and other cool stuff. But this is just the start. As it keeps going, Webb might show us things that change how we see the cosmos. One of the coolest parts of this exploration is looking for alien worlds that could have life. With more and more exoplanets found in the habitable zone, the idea of life beyond Earth is becoming more likely. Even finding simple germs on another planet would change biology, rewrite our theories of evolution, and change how we see our place in the universe. Also, looking into the mysterious forces of dark energy and dark matter will challenge and expand the limits of physics as we know it. These unseen forces make up most of the universe's mass and energy, but we don't know much about how they work. Solving these puzzles could open up new levels of reality. At the same time, astronomers are still studying how galaxies act. For example, the surprise that stars in the Milky Way's outer areas are moving slower than expected has already made us rethink our models of how galaxies work. This could mean that the Milky Way and other galaxies have less dark matter than we thought. If this is true, it could change how we understand gravity and the universe's structure. This is a great example of how new evidence can change old scientific beliefs. Also, the idea that galaxies change in ways we don't fully understand shows why we need a better way to study the universe. Could the cosmos be older than our models say? Are there parts of its story we've hardly started to uncover? These are the big questions astronomers will keep asking as more data comes in from current and future missions. With every discovery, it's clearer that our current understanding is just the beginning. There's so much left to explore, and the more we find, the more we realize how much we don't know. This constant drive to find truths and ask deeper questions is what fuels the human spirit of scientific discovery.